Good morning, everybody. Morning. Okay. Good morning and welcome to the first session today. It's about taking the right steps, quality and testing. And I can see it's a very interesting topic. There are a lot of people here. Okay, good. We have 6 presentations in this session. By the way, maybe just to introduce myself, I am Vlado Cetl, coming from University of Zagreb, Croatia, and I will be the chairman for this session. Since we have 6 presentations, I will kindly ask our speakers to be on time, to keep on time. So let's say 10 to 12 minutes for presentation so that we have some time for the discussion. Okay, not to waste our time, let's start with the first one. We have actually 2 speakers. They will change, they will mix. So the first is Daniela and then Carlo. So Daniela, please, floor is yours.
Thank you very much and good morning, everyone. My name is Daniela Hogrebe and Carlo Cipolloni, and I would like to present you some impressions or some ideas of one work package of the rolling work program of the maintenance implementation group, the work package regarding validation and conformity testing. Well, first I will give you an overview about the main objectives and the scope of this work package, and then Carlo will continue with an insight of the current work plan of this work package. So first, what are the main issues regarding validation and conformity testing in Inspire? We see there's a great need in the Inspire community for tools to validate metadata, services, and datasets in Inspire. At the moment, we have different tools for validation of metadata and services available, but these might include slightly different interpretation of standards and the specifications. Also, software vendors claim that their products are Inspire compliant without having a certain certification process. And the abstract test suite in the data specifications defines a set of tests to be applied, but at the moment there's no reference implementation of those abstract test suites yet, so you just actually can't test what is written in the abstract test suite. So the proposed change or action of this work package is to develop a commonly agreed European validator for Inspire metadata, network services, and datasets. I just skip this and come back to this later. We should establish a rule that all new technical guidance documents need to include abstract test suite and executable tests. And we should discuss the possibilities for setting up a compliance certification facility and process similar to the OGC site program. Well, the outcome of this work package should be that we have common validation tools that we can all use in the Inspire environment, that we have commonly agreed tests regarding metadata, network services, datasets, and that we have policies and procedures of validation and testing, for example, some rules how we develop and maintain the tests. Let's call it an Inspire testing maintenance framework or something else. And we will have a feasibility study of setting up a compliance certification facility and process similar to the OGC site. So that was what we have defined in the work program of the MIC. And then we had a workshop in May where we mainly discussed the scope of this work topic. And on this workshop we agreed that we should focus on testing the requirements coming from the regulation based on the technical solution that is described in the technical guidance documents. That means we have in the implementing rules different legally requirements that needs to be fulfilled to be compliant to the regulation, and that are translated into technical requirements and recommendations in the technical guidance document. And based on this, we will, on a first step, develop abstract test suites, like we have already done in the data specifications. And these abstract test suites should have different conformance classes so that we can distinguish between the requirements coming from the regulation, so the legally compliance, and the requirements and recommendations coming from the technical guidance document. And then we are able to develop or derive executable test suites, such just a piece of software that enables you to automatically test what is defined in the abstract test suite. So a few words regarding legal compliance and technical conformance. It's something different because each validator just is based on one technical solution. So you can't have the results of these validators can't be a final legal statement on what is compliant to the regulation and what is not compliant. So, but it is for the data provider, it is a strong technical statement, or the strongest one he can get, so that he can, or he's able, if he passes all the test cases of the validator, he is able to say, yeah, I'm compliant to the regulation, and I am able to fill in the conformity statement of the metadata as conforming to the regulation. But if you fail the test, it's not immediately that you are not compliant to the regulation, because your solution can be based on another solution than is given in the technical guidance document. So if you can be compliant to the regulation if you have another technical solution to implement this. So in fact, for every technical solution we have to test the legally requirements, you need a different validator, in fact. Yeah. So just to summarize a bit, as I mentioned before, the focus should be on testing the implementing rule requirements based on the technical solutions given by the technical guidance documents. We should have different conformance classes to distinguish between the implementing rules compliance and the technical guidance conformity. The ETS should be fully automated, so it's easy to use. We have one or more, maybe, commonly agreed validations for testing metadata, discovery service, view service, download service, and datasets. That's in the scope. And a process or governance of developing and maintaining the tests is also needed. And basically, the development of the validator should be use case driven. So that's overall the main points of the scope that we have discussed right now. And now I would like to hand over to Carlo.
Okay. Good morning, everybody. Now I present to you the boy part of the activity, the work plan. This activity is more or less divided in three work package. One that is more management part and policy part, is strongly related with the policy, MIG policy subgroup, and also the taking account the definition of a policy and how to can produce a conformity, a certification or a certain feasible certification compliance system like OGC, and then establish the governance part of the activity. It's more or less is divided in 4 tasks. Each task have a scheduled time and when starting, when finish, and which is the output of the task. So really we have a defining for each work package and each task all the responsible, the output, and the time when starting and finish. And if we defining different step or different documentation like a draft version and final version, we defining also when we have the first version and the final version. The second activity is related to the work package of software development, so it's more technical part. We have also here we have 6 tasks. The first task is defining the use case for a common validator, so more or less replies the scope that showed before Daniela. And then we have some tasks to derive a requirement based on the use case, and so it's strongly related for the first one and is consequential for the first one. And then we have 2 tasks related to the existing technical solution for validation, and we collect this technical solution, we comparing this technical solution and to evaluate which is the best or which is feasible to implementing in compliance with the time of the activity. And the last 2 is more related to the software development, so it's very really technical part, it's architecture design part. Also for this work package and task, we have defining scheduled time, responsibility, and output. These 2 activities, the previous activity is the first activity that we have to put in place. And the third work package is strongly related to the abstract suite and executable suite. So we develop test suites for each piece metadata. We analyzing the requirement from metadata technical guidance. We compare existing implementation metadata implemented rule requirement, and we defining an executable test in different phases. And the other one is develop the same things but for discovery service, and then we have 2 for test suites for view service and download service. So more or less we replies the same activity in different part of the regulation and the implementation, but at the end the final solution is possible to bring together, because one option is to have a common validator at the end that is able to validate all the processes. So when you have put in place all the pieces of the Inspire implementation, you have some validation that started from the beginning and arrive to the end. So also to guarantee a quality of a process. And then we investigate some testing Inspire for Dataset. We identify 2 or 3 use case that's representing pilot. At the moment we have put in place protection site, natural risk zone, and probably someone suggesting also land use, but we have to see in the next months if feasible or not feasible to implementing or starting to working on this in parallel to the other activity. And also for that we have defining some date, but at the moment we're not defining anything related to the people, but just because it is a work in progress. So in the next 2 or 3 weeks, probably we have defined all the work program. That's it.
Thank you very much. Since we are really short with the time and schedule, I will allow in the moment if it's any burning question, or I will propose that we move all the questions to the end of the session. Yep. Is there any burning question in the moment? Okay, if not, good. Yeah, there is the one.
Just the calendar schedule for the actions.
Can you use, please, the microphone, because
the time when starting. Yeah.
Because of the recording, you need to use the microphone.
Yeah, depends.
Hello. Just more information about the schedule and the work plan, because you show the date, but very quickly. So,
Okay.
And second question would be, would you do all yourself, or do you procure some developments to external companies? Or
No. Okay. The activity is based on the workshop that we have done, as say Daniela, in May. So some external small and medium enterprise also is in the workshop. So it's an open activity in terms of a participation, but the participation coming from the pool of experts of the MIG. So it's an activity of a MIG, so inside the MIG, and at the moment it's just defining a work program and scope. Then in the next, when the work program and the term of reference is in place, because it vote the MIG, and then we asking for a pool of experts for specific task. So if you are in the pool of experts and you are a skill on this, you can part of the activity, I think so. For the scheduling, we have a different time. The work package 1 is starting in May, and probably most of the activity finished for September of these years. Something is still open. And concerning the software activity, most of the activities, some activities start this month. Maybe the collection of existing, for example, the collection of existing solution, and then working for all the years, and continues in the 2015, maybe. Then if you have more question in the coffee break, because I have to escape, so, or you're asking to Daniela then.
Okay, thank you very much once again. So we move to the next presentation. It's from Sampo. So Sampo, please, floor is yours.
Hi, I'm Sampo Savolainen. This presentation was made with Matti Lankinen from the Finnish Information Center for the Ministry of Agriculture and Forestry. He couldn't make it here, so I'm now presenting this for the both of us. Now, a quick context. This presentation is very this is a real-world case example of testing services. So I'm first going to go through what we were actually testing. DIKE, which is the information center, does two things. It does ICT for the Ministry of Agriculture and the surrounding agencies, and also statistics, but we're not going to go into that. But they create a lot of software. They create software for internal purposes and internal processes of the ministry, but it also does e-services, which relates to this presentation. Now the case in question is about the agricultural subsidy e-system, e-service in Finland, which is a web-based application where farmers and other applicants may do their subsidy applications for agricultural subsidies, both EU-wide and national. It's developed for MAVI, the Agency of Rural Affairs of Finland. And what's important here is to remember that agriculture is very cyclic, and there's a very tight window. There's a 1-month window for people to fill in the application, and even that is almost too early in the stage, because in Finland people don't really know what the weather is going to be like in the summer, so it's difficult for them to know what they're going to plant that year. Now this system has been up since 2009, but this is the 3rd iteration, or maybe even the 4th iteration of the software. Now how this relates to Inspire is naturally land parcels. It's crucial for the process, of course, because that's where you plant seeds and have crops, and of course the subsidies are directly proportional to what kind of land you're using, how much land you're using, and what you're using the land for. So web tools are absolutely crucial for this process. Now, this is a screenshot of the actual application. So we have a web application where the applicants can actually draw the maps. They're able to edit the Inspire datasets. They're able to make corrections to the land parcels. If they've cut down some trees, they can extend that land parcel to that now arable land. And also what the screenshot is here showing is that the applicant is dividing a parcel into plots. So in Finnish agriculture lingo, it's you have a parcel, but you don't actually put seeds on a parcel, you just divide that parcel into plots, and those plots are then defined in the application. So here you can see that the applicant is actually drawing up the plots in the web application. And that's of course important, because when you draw it, you see what the land area of each plot is, so that your application will be more precise. Now just a few numbers. Now 60% of the applications this year were done via this web application, but what relates to the Inspire datasets, 20,000 parcels were modified by the applicants themselves. Of course they don't, there's a process for the modifications. They're not taken as is, as they come from the farmers, but still it's now an important process, and it's lessening the burden of the officials doing this job, and also making the data quality better, because the applicants have a real urge to modify the parcels so that they fit the actual world. But also this year there was an additional feature that parcels could be combined or split, which is from the process point of view, it's a difficult operation, but also from a mapping point of view and from a user experience point of view, a very difficult operation to give to a relative novice to actually do this modification of GIS. And now because of this 1-month window, even there aren't a huge amount of farmers in Finland. There's many times there are way more than 1,000 concurrent users of this application, and you have to remember that this application is not like a web form with 3 questions and a submit button. This is a very intensive application where you have to fill in a lot of data. There are a lot of checks and so on. So they're going to be using the application at least for 30 minutes or maybe even 2 hours, and they're really going to use the maps, use the other features of the service. Now on to technology. This is a rough picture of how the geoinformation is served. Now, because this talk is about performance testing, it's important to show how this architecture is built up. From the bottom, there's a GeoServer, which is doing the vectors, and it's used for WFS and WFST. The transactional WFS is used to store the modified land parcels and plots done by the users. There's an Oracle database behind it, blah, 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 but that's just simple stuff. The above is for the imagery. And there's a GeoWeb cache to do tiling. And then behind that, there's a map server, which is providing ortho images, base maps, and Inspire datasets, which are used to support this process. And now, last year, everything did not go as planned. There was actually huge problems, and the problems came from very strange things. The map server, which you see in the upper right-hand corner, somehow left processes running. Those processes didn't do anything, but they used up capacity and especially they used up other resources. Now these other resources were in the GeoWeb cache. So the GeoWeb cache requests an image from the map server or images when it needs to tile a new tile. But now these map server processes got stuck, so the GeoWeb cache got stuck. And then the application service, which serves these tiles from the GeoWeb cache, also got stuck. So a relatively small problem in the map server ended up completely overwhelming the system for more than a few times. And this was, of course, unacceptable. So, in preparations for this year, the whole stack you just saw was rebuilt. The architecture is exactly the same as last year, but still, everything was rebuilt and the configuration was changed. Now, people were very confident that the changes that they did to the configuration were correct. But now the big question is, how do you know that these are the correct changes? It's easy for you to think that it's the correct way, but how do you know for real? And if you have a 1 month window for the application to be filled out, you don't want anything to go wrong during that window. So now this comes to testing. Now, have any of you done any testing of OGC services, like performance testing? Some, okay. Now there are tools available. There's JMeter, which is very popular to do performance testing. There's Gatling, which is another open source tool, but with a slightly different approach. You can always do custom scripting. And then there are some SaaS-based load testing tools. Now the main issues that you have to look if you're doing this sort of testing is I think these three are the most important ones. Of course, you need reports, as the last bullet is, but the first is that you have to be able to generate OGC requests. And that may sound very simple, but the problem is that if you're doing performance testing, it means that you might have to do millions of requests. And you want to make sure that these are representative of how the service is used, and you want to make sure that these requests are unique, or not unique, but varying, so that you're not sending out the same response or the same 10 responses all over again, because especially in an architecture like I showed before, there's caching. So if you have only 10 unique requests, they're going to be cached immediately, and you're not going to see any of the problems that you're going to see in the real world. Now the other problem is OGC responses. Many of these load testing tools, you have to manually make sure that they recognize the correct responses, so that they're not fooled by error reports coming from the server, but anyway, there's a response, okay, it might be working. And of course, well, I mentioned reports, but JMeter is, you have a lot of options, but none of them are perfect. Gatling has a fixed report, which is pretty good, but not perfect. If you do custom scripting, then you're going to have to do custom reporting, and that's a big deal. Now, what we did, of course, the reason I'm here and not someone else is that they chose to use our product, which we use to test various parts of the layer of the architecture. This is important because, of course, the users themselves will be using all the services through the application itself, but to make sure everything is working correctly, and especially if you find problems, you have to be able to test the different layers of such an architecture as this, so that you have a idea of what's going on and what the bottleneck is. And now here I've selected a few findings that we got from the testing. This, just in short, this green thing shows you how the test is sort of planned. So there's a ramp-up time of 5 minutes, and then it's 5 minutes on a steady load. So this is an INSPIRE test of the land parcel imagery, the view service. And we were very sure that it's going to pass the test with flying colors, but we ran into, well, immediately we ran into problems. The request time is a bit erratic, and then when it comes up to the 18 requests per second, 20, it starts going up, and this is showing the average response time, and from the average, this is a logarithmic scale. You can be sure that this is not going to be 90% under 5 seconds. We tested different combinations in the map server configuration. Nothing made a real difference. But when we switched to GIFs from PNGs, everything was great. And this is a very interesting. And this is, again, it shows you when you test things that you will find out things that you didn't expect that were going to happen. Now this is then a test where we knew that this service will not take it. We deliberately made sure that there were no tiles and that everything needs to be tiled on demand as the tests were coming in. But what we wanted to see is how the GeoWeb cache works when it's really overwhelmed. And at first it overwhelmed very fast. You can see that here at about 10 requests per second, it just became totally unresponsive. Nothing came through. We noticed that there were no optimizations of the virtual machine that was running the system. We tuned, we used some different variations of parameters. We came up with this horrible little thing, which might be useful for some of you if you're using GeoWeb cache. But basically what it meant, that is, as the service was not tiled before, it was to be expected that it will fail. But it didn't fail completely. It still kept running, and it still managed to do some requests. So there was a dramatic improvement on how the service behaves. Now the last slide, which is probably the main thing that we found, is what happens when a service, a mapping service, does tiling during production. Now this test is running so that about a quarter of the requests are going into zoom levels, tile matrices which are not tiled. But after a certain point, you see that the response time goes up and the errors are dramatically gone up. So about 5 to 10% of the requests are okay by this point, and 90-95% of the requests are failing. And what you would expect to be seeing is that only the requests, the 25% of the requests would be failing because they would be overwhelming the map server, but that wasn't happening. So we disabled the on-demand tiling, and then we reran the test. And now we see that about the quarter of the requests are errors because they're not tiled, but everything else works really fine. And there's a deep reason for this, which is a lesson for everyone using tiling services. The problem is that GeoWeb cache has a single queue. Imagine all the requests going into a queue, and you have a fixed size for the queue. And now the requests which are already tiled will be really fast, but all the requests which require tiling will be slower and slower and slower and slower. So you will run into the issue that the whole queue is full of requests that wait for tiling, which comes to the point that not even the already completed tiles are able to be processed. And that's about it. And there were no problems this year. Sorry.
Thank you very much, Sampo. Any burning question in the moment? Seems not. Good. Okay. This means we move to the next presenter, Francisco, please.
Good morning. My name is Javier Lopez. I come from Spain, from the University of Zaragoza. I'm going to present our work into testing web services with a different approach. As the name says, we use an acronym, BDD, Behavior-Driven Development, which is a way for developing software that is widely used outside of our community. This work has been held for the Spanish SDI, and in the last Inspire conference, it was presented the overall idea. The goal of this presentation is to show how it's now implemented and the advantages that we have found about other approaches. First, this is more or less the outline, but as I know that we have few time, I'm going to pass the less relevant images. Well, we know that testing software is very hard, but authors says that especially when web services, and the previous slide of my colleagues show, makes that testing services, the testing system get worse. And it's obviously that geographic information has its own complexities. For example, our models are very complex, we work in distributed systems, there are many application scenarios. But Inspire is even harder, because apart of having a technical problem, we have a problem of people. Because in this case, for example, there are many stakeholders. In our teams, we can have people who are developers who have never worked with geographic information. And also, we need to work with managers, domain experts, users, that when you start to talking about how to test, for them, it's a new world, because, for example, current tools are usually targeted to people with very high skills in technical issues. For example, if you see, there are here a few references that in the GRC, for example, the validation tool for metadata uses schematron, or they present users UML models explaining where the test has failed. The problem is that this is useful for a technical people, but for the remaining people, for example, for a manager is able to understand what is happening with the test. And also there is a cultural barrier, because usually the graph, the report, and so on are expresses for technical people. But how to explain, for example, in a city, for the politician who is in charge of a department of the urbanism, that there is a problem with the system and they must to invest in order to comply with Inspire. The report should be understandable for people who are not only technical, or even people who are working in Inspire. This is an example, a real example of a piece of a text written in a schematron. I can understand this, but how many people can understand it outside of the technical world of people testing OGC web services? We should be aware that there are several people involved in this. For example, we have the developers of services. I mean, for example, GIS have a developer or a database admin who has never heard anything about Inspire, or even the system admin who is the responsible of maintaining the networks, that probably he knows that somebody needs to have a huge amount of service, a huge amount of network, because he needs for something, but Inspire, for him, means nothing. The manager for work projects, yes, they know about Inspire. But the remaining people who are not involved directly in the project, for them is another GIS project. And we should not forget the other people involved, the consumers. For example, how to explain to the citizens that this system has been improved because it's compliant with Inspire. What it means? And obviously, we should report to the people of Inspire. So the problem is a problem of communication. Testing is not only to test a system, it's to explain the test to other people. So a possible approach is to find an ubiquitous language that everybody involved in testing can understand. This idea is, the goal is to have this concept of ubiquitous language. This is a concept used in software development, and it tries to make testing more easy to us users, to stakeholders, and everybody who is involved. BDD is a technical an approach for developing software that is based in this kind of issues, on having specs written in an ubiquitous language. BDD is not quite old. It was developed in the last 6-7 years, but it has been adopted by industry in many areas. The idea is we are going to involve users and managers with developers into writing the asset test. The idea is to write an ATS in a human readable form. That is, the ATS should be understand the developers, and the users should be able to understand the ATS. In this case, the ATS usually is written in this language, which name is Gherkin, and this is the URL you can find in the description. The most important thing, these ATAs are runnable. I mean, they are written in plain English or German on Swedish, but tools can run them and run the test. And there are now a lot of tools using in the industry. There are a few ones, Speak, JVJ, StoryQ, SpeakFlow, that can run this kind of test and make the reports using the description made contained in the test. The idea of a runnable test means, okay, you write a human readable spec in Gherkin, and then you write the real definition, the real code for testing in the language that you want. In the previous one was, the first one, Speak, is for Ruby. The second one, JVJ, is for Java. The third one, I think, is for C#. And then this allows to a tool, for example, in this case, Cucumber or whatever, in runtime, merge both the human specs and the running code and execute them and produce the reports. This is an example of, next we are going to see a real one, of the structure of a step of a spec in Gherkin. The idea is that these kind of tools can, from this kind of little specs written in plain English, German, or Danish, create a stub of code that implementers can finish adding the remaining lines of code required to test in an OGC server. This is a real example that we are using in our platform. This is a test for the requirement 50 of webmaster services. YTC, this one. The most important thing is that is in red and green are the lines that are being in runtime to the code, and more or less this is the report that the command line can provide. In this case, we say that the test has passed the two first line and the third has failed. If I present this to a stakeholder who is not developer, who is not technical, he can understand better what has happened. The most important thing is that we have studied that BDD is compatible with the geographic information tradition. I mean, for example, we can find a mapping between the concept of BDD and the ISO 19105. For example, when you talk about an ATS, in this world they talk about a feature, and we talk about an ETS, in this world they are talking about the scenarios and the state definitions. The strongest point is that the ATS, thanks to this, are executable, formal, although currently in the tools that are available for the industry, they don't support, for example, some features that are very typical in our field, such as hierarchical ATS, conformance levels, and so on. And there is no support at all, for example, for having conditional requirements. More or less, and this is very fast because if you want to know more about this, 2 weeks ago I presented this in detail in the Agile conference, and this is published in the proceedings. This is the procedure for developing this kind of test. As you see, the first part is to work with the stakeholders in order to describe the system, and when you have the ATS, developers can start to work. And finally, the system can produce two kinds of reports, one from stakeholders and other for the people who are more technical. Why should this approach is applied to Inspire? First, we are using a high-level language. I mean, when we write a test, we write in English, in Spanish, in Danish. The problem is that alternative usually is based in schematron, XM schema, and so on, who makes harder to describe what is going on. The second is developer-friendly. The main issue with the usual approaches is that we have developed niche tools that, for example, for a developer is like living in a nightmare. This is very difficult to test, to debug the test. It's very difficult to find supporting platform and so on. As we are using something that is widely used by the software engineering, by software developers outside of our world, we have a lot of support of tools. For example, from IDEs such as Eclipse, NetBeans, Visual Studio. Now this tool is available, and now it's in our developed node in our university. It is planned to be installed in the Spanish SDI or in the portal of the National Geographic Institute of Spain. It's a multilingual tool. Only you need to add the link to your web map services or your web coverage services. That are the two kind of catalog services. That are the two services that we have tested from the technical guidance. The technology used has been for the front end, the Grace platform, and the back end has been one of the tools that support, in this case, BDD, who is Cucumber, but we had patched Cucumber to solve the issues that we have found previously. I mean that all the issues that were not available in the current technology we had patched, and also part of the code is now available on GitHub. You can see that code in GitHub. And if you go to this portal, you can find, for example, if you put an URL to your service, you can see this kind of compliance report with the different requirements that pass or not pass. And this is an example of the report format for the web. In the same, it contains nearly the same as the HTS that I saw previously in Gherkin, just rendered to the final user. The current status is that we have implemented about all the ATS that are here, and the steps. Each ATS in this approach can be decomposed in smaller steps. So we have specified 428 steps. The most important thing is that, thanks to the structure of the approach, we only need to implement as real code only 72, because many of them are reusable across all the tests. That's right, that only 20 of the different requirements of the specs haven't implemented yet, because they require human supervision, and this is not yet implemented in our platform. Our future steps, well, we need the user feedback in order to improve the quality of the description of the test and even discover use cases that we haven't missed. And also we want to support more, because only we support view and discovery, but we need to support download and others. And finally, other of the future steps is to analyze the technical guidance from our experience. Because, for example, we have discovered a lot of problems of redundancies, dependencies, inconsistencies, something that seems to say, okay, how to implement this, and especially try to discover the state matchings that can model, because it is possible, the specs and which the expected real behavior that, in this case, the technical guidance are implementing. So thanks for your patience, and I expect your feedbacks and comments, especially in the moment in the coffee. Thank you.
Thank you, Javier. Any burning question, maybe? Yes, one. Just a second.
From where did you get the abstract test suite for Inspire Network Services?
We created them.
Can you use my...
Sorry. We created them. We get the original technical guidance, and we literally, if it was possible, we transform it into, we map it right to the Gherkin language, or as we have a lot of experience with that, we created the different possible combinations in order to understand that they said. It was a work about, a hard work for the people, and we, after doing that, we passed it to the National Geographic Institute in order to be in review, and they agree that they are very confident that they're okay. But the most important thing in this approach is that if you don't like this ATS, it's very easy to change them and probably reuse the use code. Because I think that, as was previously said, we need to start a process that many people should start to say, and assess how the data should be. And writing in this way that make very easy to implement them, test, and again to get feedback in order to change, I think this is a good approach. Something else?
Maybe later on the coffee break.
Thank you.
Thank you once again. Okay, we move to the next presenter, Anders.
Okay. Good morning, everyone. My name is Foureaux. And I need my own clock here on the desk. I work at the Swedish APA in Sweden, and I'm going to talk about quality control service for inspired data, especially environmental monitoring data. So, this is mine, I think. We have a quite distributed data management in Sweden with several different contractors all over the country. And each contractor is supposed to deliver the data to some specific data hosts, and there are about 10 to 15 other authorities, universities, that are quite skilled in handling data, but especially they know about the content. So we need their expertise. But we have some problem with this distributed system. We have been running it from about mid-90s. Before that we had one central database, but it didn't work. So therefore we invented this data host concept. It's very time consuming for this manual quality assurance process. So it takes much too long from the data collection to data really can be useful or used. And it's quite hard for a user to find relevant quality information when they collect the data. There are offshore certainly quality information, but it's hard to find and it's written in Swedish. So last year we developed a validation service for especially environmental data, and it's a pilot. In fact, it's two pilots, but the validation service is an FME engine that we use. We didn't want to create any new application. We want to buy the service and buy for the processing. But of course, we have to define all the specifications. So these 6 goals are what we are trying to solve or fulfill. We have lots of specifications. They're quite old. They're good, written in Swedish, as I said, but they're not so precise, so a machine cannot find out if the data set is in according to that Swedish paper. We have about 150 different manuals or similar specifications. They are good, but not precise enough. So we looked at this ISO and OGC standards for quite lots of them, and we found one called Data Product Specification. It's this ISO 19131. And we tried to use that to put all the requirements in one paper. So we have this, all those pointers to other standards or requirements. You have this data model, you have this object type catalog, and all that we need. And based on that data product specification, we can create an XSD scheme. I come to that later. But the main goal here is to use the same, as far as possible, the same standards that come up within the INSPIRE directive. This is how it looks like, a piece of paper. This is one of our data product specifications for metals and contaminants in sediment. We have another for contaminants in biota and air quality measurements. This is not so beautiful, but it's in Excel sheet. I think you're familiar with that reporting sheet in Excel. That's what we use. We have these fields for what's mandatory and what's voluntary. This is another one for air quality in cities. What happens, we take this, the contractors, they deliver the reporting sheets with fill in all the data, metadata. And when the file is uploaded to this service, the first that happens is that it translates into XML according to the observations measurement standard. So you have a transformation process immediately. So then we have this Excel format, and this XSD scheme checks what's in that XML. And this XSD scheme is according to the data product specification, according to the data models and all those code lists. What comes out of that process is an email that if everything is okay, the data host will receive it, and of course the uploader. With the data, both the Excel, the original Excel file, and the XML that has been transformed. A piece of HTML file that is telling you in a proper language if how it works, like a compliance message. And then finally, metadata field according to the ISO 19139. I'll come to that later. It's possible for us to store this into a central file server, but the main road is to the data host. This opens up for different gadgets or iPads or mobile phones for collecting data, or even sensor observations. Our code lists, we will have to deal with those problems. At the moment we have lots of different clones of code lists. We have been doing this for several years in Sweden. So I have to tighten this up a bit. And we are looking right now at the Inspire registry. That could be one candidate, perhaps a clone of it to have it in Sweden, and then some kind of web service feed to the central registry at JRC. The same with the data dictionary that EA has got. There was a little map. I come back to that. This is the registry that is set up for Inspire code lists and codes. This is the one that EA has got for about 10 years. The EA, there it is. The EA system is built initially for their own needs, because they receive, I think, about 350 international reportings from all the EU countries. So they have to deal with the same problem that we have to deal with this on this national level. But perhaps we can have some kind of collaboration with them, or we pick up this system as a Swedish clone. The other project is to get some proper order of our monitoring station networks, or monitoring stations. At the moment, this is a WFST service. That is one of the core services that this validation tool must use when they are checking the incoming data sheet. The validation service is based, as I said, at FME software, and we rent it pay per processed megabyte. And the OGC, the station dictionary is based on WFST standard. This is how it looks like. For a user or a contractor, a simple website. You can upload the file, tell who you are, and where the file is going to get. If it's all right, you get an email, and this is the content of the email. The compliance report, the original file in Excel format, deliver note, and yes, and the last file, the XML that has been transformed. If it's not okay, you just get this message that in HTML format that this wasn't okay and what has gone wrong. In this example, there was a station missing in this station dictionary. So this is the feedback. Not just one station, I think it was 10 stations missing. And the point is to have these quality checks on the fly and create this ISO file according to 19139, is that then we have it in proper XML format. So if we do further checking that the data host is supposed to do with some third-party tool or something, perhaps they will add some kind of quality information in a secondary quality testing phase, and then they just can hook it up on this XML file. But the main business for this service is to use the machine to do this. Right. So, 10 minutes to do the machine, do the boring job, and free the scientificians' brains to do much more qualified work. On the last slides, it's just a summary why we use this cloud-based. Actually, it's not up in the cloud yet, but when we pick it up in the version 1.0, we will have it as a cloud service. If we have it in one place, we can reuse it for all of the contractors in Sweden that are dealing with this monitoring data. We are taking this step by step. We're not finished at all because the deeper you dig in the quality issue, the more questions pop up. I think it's that what I just said. This is some of the standards that we have picked up. The core, the data product specification, are gathering all those pointers or pieces of other standards. But these are the main standards, the observations and measurements, and the quality standard for geodata, and the metadata standard. And for the end user, perhaps we can finally have this data. When you download data, you get this XML file with a quality file in this ISO 19331, or visualizing an HTML page or something. Right.
Thank you very much, Anders. Any burning question in the moment, or no? It seems not. Good. Okay, then we skip. Then we move to the next presentation. Giacomo, please.
I have to admit that after the Francisco's innovative presentation, I feel more like a prehistorical man, human being providing some old stuff. But anyway, I hope to be effective in the same way, more or less. First of all, sorry for there is an incomplete part in the title, because as you are aware of, starting from mid-April, also Annex I, data teams of Inspire, contain an abstract test suite. And then I would like to share the work with my colleagues, Fabio and Stefania. So a short summary. We will talk briefly about the overall concept of data validation. Then we will see how we are moving from ATS to ETS. And then a first glance of the EM Plus validation service that we are working on in the frame of this EM Plus EU-funded project. So as it has been already mentioned in the previous presentations, the ATS included in the Annex A of the Inspire data specifications is the starting point for the conformance testing process of datasets. We will talk about datasets here. The ATS consists of several conformance classes, each relating to a specific set of requirements. And each conformance class is identified by URI according to a pattern established. The ATS is divided into two parts. Part one, which is called normative, includes tests aiming at assessing the conformity of GML datasets to implementing Rule 1018 and this successive amendment 1253 of December 2013. Part 2, informative, includes testing aiming at assessing conformity of GML datasets to relevant INSPIRE data specifications, technical guidelines, and if you follow if the Part 2, you make also the Part 1, but at the moment we are focusing on Part 1. These are the table which is taken from the template for data specification, but even though there are slight differences, each data specification can have a different subset of single tests. And as you know, in the data specification, there are, in the abstract test suites, there are also, for each single test, it is included a test purpose and a test method. I am honored to take this slide that Mr. Chairman, you presented 2 years ago, with this simple addition that, based on our opinion in the concept of also ISO 19105, the ETS can be also made by tests automated and executable by a machine, but also some manual tests in order to test the physical implementation. And so this is the picture we are working on currently. So from the ATS contains several conformance classes. Each conformance class contains a sort of tests, abstract tests with test method, test purpose, and so on. And then on the right side, some of the, as we will see, some of the abstract tests can be merged into one executable test, and the set of all the executable tests will form a so-called executable test suite. An example of how tests associated to the Part 1 have been implemented for a land cover dataset transformed according to the land cover raster application schema. Here there is a description, and we focused on, at the moment, for the conformance class A1 application schema conformance class. It consists of 7 tests with a description here, and then, for instance, for tests A11, A12, A14, and A15, we made these automatically, as we will show in a while. For other, we documented that they are not applicable. And for other tests, particularly those related to constraints, we made them manually as a first attempt to automate what can be done manually, of course. This whole harmonization exercise, which we believe could be interesting for reuse by you, is documented in 3 best practices available in the INSPIRE Best Practice Catalog. We have 3 documents with 3 technical reports with also the GML files to be downloaded, how to encode the raster dataset, how to include also the metadata, not only the metadata for discovery, but also the metadata for interoperability, and then how to assess this degree of conformity. Regarding this last point, I would like to mention that according to, if I'm not mistaken, the recommendation number 26 in the data specification, because we achieved compliance, conformity with respect to only one conformance class, you have the possibility, and you are very encouraged to document in the metadata conformity element, which is the conformance class you are conformant with. Not necessarily you have to assess the conformance to, of course, in order to claim conformance, you have to pass all the tests. But in case, as here, we pass the test for one conformance class, you can document this in the corresponding metadata. So, the validation service that we are working on. is an executable test suite that implements the ATS where possible, and we would like to minimize the number of manual tests in order to try to automate all of them. So when possible, tests are automated by means of schema validation tools and or rule languages like Schematron. Tests which cannot be automated are executed manually, at least following some protocol, some procedure before to be automated. And this service is implemented as a web application by means of the use of the OGC Team Engine tool. This service provides an implementation of the ATS included in AnnexI, making use of the free testing facility GML 3.2 Conformance Test Suite developed as part of the OGC site program to verify the conformance of GML data with respect to ISO 19136 and to the relevant GML application schema. It automatically verifies the conformance of GML datasets to INSPIRE requirements for those tests of the ATS that can be automated, and the GML dataset to tests can be uploaded also from WFS or from local and or web resource to be inserted as URIs. Allows to verify additional constraints by means of theme-specific files of Schematron rules that we are going to develop, or also by user-provided Schematron files. Provides guidelines to manual execution of tests that cannot be automated, and provides also a web report to display the validation results. In terms of planned development, in green are the things that we already achieved in more or less 1.5 months. We started our work. So the creation of an access page. We are working a lot on, because this tool is very powerful in our opinion, but because OGC does not test anything with respect to, strictly with respect to INSPIRE datasets, we worked a lot on the interface in order to facilitate the work of the user in order to be guided into this ETS. And we are creating, with the support of the community, also the library of Schematron files and guidelines to execute manually the tests, waiting to be fully automated. And also some further customization of the validation report. Here there is a waiting to be migrated into the EM Plus infrastructure, which is in course of finalization. At the moment, the service, the prototype is available here. This is the screenshot in which the user is immediately guided to see how he is moving, where he's moving on in the full process. And then when you select on the drop-down list the relevant theme you are working on, then for instance, in this case, the land cover, it appears in the second page the complete set of abstract tests, and on the last rightmost column the executable tests to run according to this specific ATS. And clicking, for instance, on one of them, which is already implemented, at the end you have here the picture of which are the tests, of the full tests that can be done, and then logging in, you can upload your file to make the validation. At the end, this is the report, which is using the OGC stuff, very useful, because clicking on for instance, on the one of the group of the left part, you access all the details of the test. At the moment, it is quite important to mention this aspect in terms of cooperation with OGC, is that because also they are running some beta version. 2 months ago, the same test, the same file passed all the tests, but a few days ago it did not pass, and we discovered that there was an error in the schema, in the base type schema. So it was quite strange, and we, for instance, with Altova XML Spy, the test passed. So we entered into contact with OGC in order to see, within their development, if some mismatch occurred in order to be fixed. It's very important, this cooperation. And just the last 2 slides to conclude. Among the different alternative solutions considered for this implementation, we selected, why we selected? Because in our opinion, Team Engine is an open source Java application provided command line, so customizable. It is the official test tool for the OGC site program, where it is used to certify many other stuff. It is a tool being set up by other organizations to help community involved in compliance testing, so we can benefit from the collaborative work. And last but not least, it is part of and well fits in a wider collaboration framework scenario among EU-funded projects, CENTIC 27 and OGC for an effective use of geographical information standard. It has been already presented during the workshop of sub-project 5, validation and conformity testing of the INSPIRE Maintenance and Implementation Group, JLC last month, as one of the contribution to achieve everything. It has been also presented at the OGC site subcommittee meeting in Geneva 1 week ago, in which I think I would like to report to all of you the very important willingness of OGC to cooperate with INSPIRE. Very minor detail is that I've been very gladly nominated as a co-chair of this committee in order to ensure this cooperation. But the most important part is that I think that thanks to this kind of cooperation, we can align many differences that can be in different tools in order to, at the end, ultimately support the community involved in validating datasets and implementing INSPIRE. Thank you very much.
Thank you very much, Giacomo. It was a very interesting presentation. Any burning question or no? Perfect. So we move to the last presentation, and then we will open the floor for the questions, okay? So the last one is from Anne.
Thank you very much. I think my talk will be a bit atypical for this session, and I apologize in advance because I will try to rush through some of my slides since I thought that after my intervention of yesterday at the plenary I ought to say a few words about quality. So first of all, I say 2 words about a little Belgian project which has 3 partners, 3 Belgian research institutes specialized in atmospheric studies, marine and meteorology research. This is a project sponsored by the Belgian Ministry of Science Policy. It's a very short one. It will last 2 years. And it's been funded to explore concepts related to documentation, that is metadata, and quality assurance of atmospheric and oceanographic data from the Belgian federal portfolio. As you may know, Belgium is very small, but it's a federal state. And we would like to do this in compliance with the international standards, including INSPIRE. It has got 5 main milestones. We intend to develop a validation protocol, provide a template for validation reporting, develop a metadata model that will serve as a basis to a metadata editor, complying with the INSPIRE editor online on the GeoPortal, and finally provide a catalog which will be available through a web portal also connected to INSPIRE. So obviously the project is related with INSPIRE in a few ways. First of all, it deals with the 3 data themes listed in Annex 3, atmospheric, meteorological, and oceanographic features, but also to a number of other more loosely related themes. And it has in common with INSPIRE the concern of harmonizing metadata and easing the data search and exchange. Hopefully Pamir will contribute to help integrating the Belgian data into the INSPIRE network, and who knows, it might contribute to further shaping INSPIRE as well. There is a related Belgian project which is called INIT-GeoBE, which will set up the national portal in Belgium, and of course the 2 projects are related. Now I had intended to give you a flavor of the types of data sets we deal with, but I will go very quickly through these. This is an example of ocean data that are a function of time, its particle size. Another example coming from ocean data, it's the sounding of the ocean along the path of a cruise, and you see, so the ship went from Ireland to Greenland, and plotted there is a geostrophic velocity according to longitude along the path and depth. Now my colleagues from the Belgian Met Office will provide precipitation data measured with radar, derived from reflectivity and radial velocity. And this is an example showing a storm coming to Belgium from the south. And if you focus on the little section reaching Belgium and run a straight line through the eye of the cell, you can plot then the intensity of the rainfall as a function of altitude. This is another example of atmospheric sounding with balloons, providing a number of variables as a function of pressure, which is another way to represent altitude. For example, the red line is temperature. Now, my institute will provide a number of other data sets, and this is an example of data collected with Max-Doa spectrometers, which measure scattered solar light at different elevation angles. And from the spectra collected, they observe the signature of atmospheric components, and they can derive profiles of such species, again, as a function of altitude. These are formaldehyde and nitrogen dioxide over the region of Beijing. So you got my point. I think there is, all our data sets are fully dependent on the four space and temporal dimensions, not only longitude and latitude, of course, but also the vertical and time. And this dependency on the last two coordinates is often, well, certainly in most cases, the most important feature of the data set. So that if you reduce the data set to a set of horizontal slices, you actually lose the most important piece of information conveyed by the data. And so, although our project will not directly deal with inspired data models, these models reflect on the metadata, and we will work with metadata. So we hope that at some point INSPIRE might update the data modules in order to fully represent four-dimensional data. Now I'm coming to quality. You will see that I will use quality and validation in very different meanings as the meanings that have been used so far in this session. What quality information a user of ocean and atmosphere data needs in order to be able to assess whether the data set is suited for his application is listed there. It's not an exhaustive list, but you can see that at the center of it are listed quality indicators, that is essentially uncertainties, which are aimed at assessing how close the data is from the truth that you don't know. The provision of quality indicators is a central requirement of the Quality Assurance Framework for Earth Observation, which has been set up by the Group on Earth Observation. And as such, we are supposed to follow their principles. One of the things we are going to do, as I said, is to develop a validation protocol. BIRA, my institute, has a certain expertise in doing that. We have been doing that for a number of previous projects already. At the center of these validation protocols is a core of general principles, a kind of checklist of things that you should not forget. At the center of it, you see that user requirements play an important role. So it's a set of things that have to be done. But again, it's not meant as a validation of the conformity of a data set or a metadata set to some formal specification. But the aim of it is to assess how reliable a data set is, how usable it is for a user. For example, this is an end-to-end validation of the retrieval chain for the ozone SAF. Now, if we come back to INSPIRE, as you know, in the metadata model, there are two metadata fields intended to give account for quality information, lineage and spatial resolution, and here spatial means horizontal. And lineage is the only field where information of quality may be provided, any type of quality information, including, of course, the one you have presented so far, which is related to the conformity to formal standards, but also the quality in my meaning. If I can say so. And then the second one is the horizontal resolution, which for Earth scientists is a mere characteristic of a data set. And actually this is also true for maps. You could very well have a map with showing a wrong feature, and it's not by increasing the resolution that you will make it more true. On the contrary, you will actually make it more wrong. So it's very important to provide the spatial resolution. I agree totally with that. And also it's important to provide information on how compliant a data set or a metadata set is with formal standards. It's absolutely crucial. But it's not the only thing which is important. And for scientists, of course, there is a more fundamental question which is related to how realistic the data is. So to finish with Pamir, as I said, we intend to provide a metadata editor that will be able to ingest the metadata in a number of forms. This metadata will be translated into XML files that will underpin the online catalog, and we hope to be able to ingest those into the INSPIRE metadata editor. But this, as I just showed, will require some transformation, not only because our metadata set is likely to be more abundant than the mandatory INSPIRE metadata, but also because it will be structured differently. We already have a sketch of a website. There is not much behind it, but we hope to populate it in the next month. And this was the end of my talk. But I would just like to add a couple of words regarding the concept of quality that I addressed yesterday morning at the plenary. I was answered by Mr. Conrad, the chairman, that he had not been expecting technical questions to be discussed at the plenary. But this was not at all a technical question. It was a very, very, very fundamental question. I'm not a technical person. And I think the question has to do with the reasons of our actions. Do we want to distribute data for the sake of distributing data and making people busy? Or do we want to distribute data because we think they convey some message about reality? And if we do, and with the idea that this helps us interacting with reality, of course. And if this is the case, then we should give ourselves the means to do this properly. And the question is that, well, scientists know that any data is wrong. This is a little provocative way to put it, and it's of course uncommon to say that in a public. Most people think that exact science are true, but scientists know that data are always wrong. They are wrong by definition, in essence, and the whole question is to assess how wrong they are, and it is very important to do that. So I will finish with those words.
Thank you, Anne, for presentation, but also for raising up this issue of data quality. So now we are at the end of the presentation, but however, we still have time, and I think we can still few minutes before we go to the coffee. So I'm opening now the floor for the questions and comments. Yes, we have one immediately. So I will go around with the microphone because we need to use it. So not questions only to Anne, but to all presenters.
Try and turn it into a question towards the end, and it is on the last presentation. I completely agree that every data is wrong. Sorry, I'm Peter Parslow from the Ordnance Survey in Great Britain, so like a traditional core Inspire kind of thing. We know our maps are wrong. We're always trying to assess how different they are from the real world. And I think every community has metadata beyond the couple of things that are in the core in Inspire, and it's completely normal for every community to make its own editor, so and to create metadata records that are more populated than the absolute minimum, as you say, in order to be useful to the people who are going to use them. So I appreciate the being provocative, and don't feel we all ought to do it more often. I think the question, I suppose, would be, am I then alone in that? Are only the two of us who think that all our data is wrong and we just need to measure how wrong it is? And I suppose my word of encouragement is, yes, add lots of extra elements, but I would encourage you first to look at the underlying ISO standards that have got hundreds of elements in them, covering all sorts of observations and measurements. Before starting off on a new structure, even the underlying standards have mechanisms for extending them with even more stuff. But so a question almost around the room: does anybody actually think their data is correct, or are we the only two who are willing to admit it's wrong? It's not so much a question to you.
Yes, well, I'm a scientist, and I have chosen to do that work because I believe in science, and I believe in the usefulness of data, of course. Yeah, but I do insist that I think that focusing on formal aspects of conformity and validation presents the danger of losing sight of the actual question I mentioned. It's just an incentive to not to forget this, and perhaps to develop it a bit more and make it a bit more systematic and Inspire. I think it's an important point.
Thank you for the comments. Any other questions? Yeah.
Yes. The question is for the Spanish presentation. Would your method be adapted also to validate data and not only services?
Okay, yes. The approach can be, although we have used it for validating, in this case, services, is agnostic. I mean, it's an approach that can be used, that in software is using for testing anything that you can test with a program. The idea is that the specs are written in something that not only developers, but also stakeholders can understand. So, although it's not in our plan, it's reasonable to do that more probably later. But it is possible to do that. Is that not with my tool, but it is possible to do with this kind of approaches. Because the idea is that we should start to look in other communities, especially the people that now in the industry, in the software industry, is testing a lot of systems to check, especially tools that are not niche, which is the problem with the tools that are developed by UGC. But the problem is that, okay, in this room, how many of you are developers? The remaining are the people who demand developers to do something. And probably the people that you're looking for are people that are not aware of what means something that's datum, or they don't know anything about coordinates and so on. There are people that are, for example, for the university that has finished his degree in computer science and so on, and they start to work. So the problem is that you should start to think that probably the people that should implement Inspire are people that are unaware of what we have been doing inside of our little community the last 10 years. And I think that this is a point that should also be aware, that there are many work in developing, in testing and so on, outside of the OGC world, and in a way the geographic community.
Thank you. Any other questions, comments? Or we are all waiting for the coffee break? It seems so. So probably we can post some question in the coffee break, but let me conclude this session. So just to summarize a little bit, I think from all the presentations, actually we saw a lot of possible synergies, and this is important to collaborate. So there are a lot of, it seems, validation tools and applications already running. There are a lot of in the progress, so please reuse it, especially in the MIG working program. So I think you are already collaborating, more or less. And yes, that will be it for this first session. So I would like first of all to thank to our presenters and thank to all of you to be with us on this first session. Thank you very much.